Welcome everybody. It's Ramchandra from CIVIL-MECH-MATHS CONCEPTS. In this lecture, I will be covering about the fluid statics, which is very important topic in the point of view of hydraulics and also fluid mechanics for civil and mechanical engineering for SSC JE, RRB JE and UPSC and GATE examinations. Kindly view, review and comment, and if any subject, any topic is not understood, kindly make a comment so that I will reply with an answer to your questions. Best of luck to everybody. It's Ramchandra again from CIVIL-MECH-MATHS CONCEPTS channel. Kindly see my other fluid mechanics videos also. Already I have released 5 videos on the topic. Best of luck to everybody. Thank you. Welcome to everybody. It's Ramchandra from Civil Mech Maths Concepts. I have released 5 videos on fluid mechanics for the benefit of GATE, SSC JE, RRB JE, AE, PSC and UPSC examinations. I have started with prelims and properties, and I have come up to fluid properties, surface tension, viscosity, everything I have discussed. I prepared certain MCQs also with in-depth analysis, and also I have completed pressure measurements and different types of gauges being used for the pressure measurement. Pressure measurement, gauges and manometers, and given concepts on atmospheric pressure, bar, gauge pressure, vacuum pressure and absolute pressure. As you know, as I explained in the previous lectures, a fluid can be either a gas or a liquid. Either a gas or a liquid. In this lecture, I will be discussing about the fluid statics. A fluid can be static without moving. Fluid is not moving. Static means not moving. And a fluid can be dynamic also. Dynamic means it is moving. And there is a transient movement by the fluid. Static means there is no movement of the fluid is stationary. Before taking up the dynamics of the fluids, in this lecture and for subsequent some more lectures, I will be discussing on the statics of the fluid. The pressure definitions you already know, and the statics of fluids we will understand now. If the fluid is a liquid, then if it is a liquid, liquid statics can be hydrostatic. And if it is a gas, gas statics or aerostatics. If a fluid in the form of liquid is static and not dynamic and not moving anywhere, then it comes under the hydrostatic classification. And if it is a gas, then it comes under the aerostatic classification. Because there is no movement of the fluid, we can say there will not be any kind of deformation and there will not be any viscous forces or viscous stresses being discussed here. We will be discussing the normal stresses. As discussed in the previous classes, what is the unit of a stress? Stress is equal to units Newton per meter square in SI units. We will be dealing with SI units only. This can be kilonewton per meter square, meganewton per meter square, and 1 Newton per meter square is equal to Pascal. And this can also be, units can be Pascal, which is Newton per meter square, kilopascal, megapascal. And we have discussed about the atmospheric pressure, bar, gauge pressure, vacuum pressure and absolute pressure. Now, in fluid statics, if we consider hydrostatics as an example, then the variation of depth you have already seen. If, let us say water, liquid or water we can say, it is there up to a height of h, in a vessel with some wall thickness, then at the top there will be a atmospheric pressure. This pressure can be denoted like this, and with depth the pressure varies like this. If P atmosphere, which is the datum, if it is taken as 0, because pressure usually measured as a difference, delta P, then the pressure diagram can be like this. If it is the wall, then towards the wall pressure will be acting like this. Now, this is rho GH. This is the variation of pressure with depth. In detail, I have discussed in the previous lectures also. Atmospheric pressure, how it varies. with height, that's also we have discussed. Delta P is equal to rho GH. With this background, we will be taking up various case studies for calculating the hydrostatic pressure. Let us take hydrostatic as the example, hydrostatic pressure on a particular surface. Let us take a plane surface. Plane surface means it has no curve. Horizontal plane surface. Undulations are not there on the surface. The surface is plane because of the absence of the undulations. Let us say it is XY plane. And this is the plate. A plate is there on the XY plane. This plate is called as horizontal plane surface. And if I take it in three-dimensional view, it will be like this. Here fluid is there, fluid surface. Let us draw an isometric view. This is the plane surface. This plane surface, let us say this is X and this is Y and this is the Z. In Z axis. And this is the plane. I will draw it with red so that you can understand well. This is the plane surface. In XY plane, and it is at a depth of h from the free surface of the, this is free surface. Free surface means it is not free, it is subjected to atmospheric pressure P at atom. P atmosphere, if we take it as 0, then from free surface, if the plate is kept at a depth of h, then whatever the forces act on the surface will be perpendicular to the surface, which I have already told you. For the XY plane, Z axis is the, Z direction is the perpendicular direction, like this. X and Y are perpendicular to each other, and X and Z are perpendicular to each other, Y and Z are perpendicular to each other. Three mutually perpendicular axes in a 3D. And these three mutually perpendicular axes, and for XY plane, Z is perpendicular. The Z is perpendicular to the XY plane, 90 degrees. That means this is acting F normal. The normal force on the plate and the area of the plate is in the xy plane. If I take A and B, A as the breadth, B as the width, then in which area the perpendicular pressure is acting, force is acting, this F perpendicular is acting, pressure on the horizontal plane surface will be perpendicular force by area, that is A into B. That is equal to rho GH, because we know variation of pressure with depth. At a depth of H, the pressure will be rho GH, that is equal to normal force by A into B. This acts at the centroid of the surface. Even though pressure distribution is there everywhere on the plate, forces are acting, pressure is there, but at the centroid of the surface, center of gravity or centroid of the surface, pressure is equal to F by AB, that is equal to rho GH. That implies force is equal to rho GH into AB. From this, we can say normal force is equal to rho GH into AB. Then this normal force, pressure force is equal to, what is rho G? This can also be written as W. This is W. WH, AB can be written as area of the plate, implies pressure force is equal to WHA. This is very important formula, please remember this. Or it can be written as WAH. Very important formula, please remember this. That means pressure on a horizontal plane surface acts at the centroid of the surface and the quantity of it is quantized as pressure force is equal to WH, where H is the height of the fluid from the plane surface to the free surface, and W is rho G, rho is the density, G is the acceleration due to gravity. We can even say W as specific gravity. Now P is equal to WAH, or it can be written as rho GAH. to be more specific. Now, this is what is about the horizontal plane surface. You have to understand the importance of the pressure. Pressure can act on any object, and we have considered for a plane surface, horizontal surface. For example, it's not a horizontal surface, rather I kept the plate vertically. For example, I'll show it geometrically like this. Please try to understand. It's very, very, very important. These concepts, how vertical plane looks like. Horizontal plane is free surface, and in the z axis, and a plate isometric view like this, and this is the centroid. From centroid it is the H. Then this is the force, normal force. The normal force or pressure force is equal to rho g AH. This is for horizontal. If I have taken a rectangular plate, don't take a rectangular only, you can take of any arbitrary shape. Don't worry of this rectangular plate. Okay, only for ease of understanding I have made like this. Now, the plate is there, this is the free surface. Here it is P atmosphere. This is the free surface, fluid free surface. Then if the plate is kept like this, it's not a horizontal, it's vertically kept. When something is kept vertically, what happens? Pressure will be acting perpendicular to this surface Let us say here we have taken Z as the height. This is as Z. Let us take Z, no problem. As far as reference are there perfectly, once we have taken the references perfectly, then we need not worry. Now, as in the horizontal surface, in case of the vertical surface, let center of gravity be here and the height of fluid column above the center of gravity is equal to h bar, then the force F is equal to rho g h bar into A, where A is the area of the surface. This is for vertical plane surface. Vertical plane surface. In case of horizontal plane surface, rho g ah. In case of vertical plane surface, rho g a h bar. H bar is the height of the free fluid surface from the center of gravity of the vertical surface. Now, from the basics of physics and mathematics, clubbing both physics and mathematics, we have to calculate what should be the h bar. For that, we require the definitions of moment of inertia and the center of gravity. H bar we have calculated. Now, on the basis of the shape of the surface, which I will be discussing after some time. I am not complicating the things. If it is a horizontal surface, it is rho g h a. If it is a vertical plane surface, it is rho g h bar a, where h bar is the height of the liquid free surface from the center of gravity of the vertical plane. Now, this is the center of gravity. Now, there will be another, in the vertical surface, there will be another point also called as, this you call it as center of gravity as G. There will be another point called as center of pressure. Center of pressure. This is at a height of, this is called as center of pressure Cp. This is center of gravity. Center of gravity is for the surface. Center of pressure is for the total pressure where it is acting. In a horizontal plane, center of pressure and center of gravity are same, whereas in case of vertical pressure, pressure will be varying with depth. Pressure will be varying with depth. As the pressure on the point A will be different from the point B, it will be different from point C, it will be different at point D, it will be different at point E. If you make slices of the vertical surface for a height of dh, Then those slices, pressure on point A will be different, pressure on point B will be different, pressure on point C will be different, and the center of the pressure, the center at which this pressure is acting, is called as the CP. That point is called as the P. This is the center of the pressure. Whereas for a vertical plane, center of gravity is center of gravity. That is a plane surface, it is constant. Whereas center of pressure is not constant. Depending upon the depth at which the plate is kept and depending upon the plate surface and the height from the free surface, the center of pressure varies. The center of pressure is here, for example, in this example. Now let us take another example like this, where your vertical plate is very near to the surface. This is center of pressure, this is center of gravity, this is H bar. This center of pressure, H star, let us say H star, this depth may be 100 centimeters here. Let us say, for example, this can be 90 centimeters because the distance between these two, free surface and the top portion of the vertical surface, is different from here to here. You just see. In both the, try to understand this concept very carefully because concepts are very, very important. This is, let us say, M, N. Here it is M dash, N dash. Mn is not equal to M dash, N dash, which implies here H star dash. H star dash is not equal to H dash, H star. Even though the center of gravity is lying there only for the surface, center of gravity for the plane is at same point, but the heights H bar, H dash bar, H star slash, both are different. Center of pressure differs from the height. This concept you please try to understand. Then, how to find out the center of pressure? This is found out with the help of moments of the resultant forces to be calculated. When you calculate the moment of the resultant forces, we can get the center of pressure. Center of pressure can be calculated, for example, about this point, I am taking a moment. That means F about this surface, about this point force is acting, and about this surface I am taking a moment. Please see, this is the surface, this is the force acting, and it is acting from a height of h. What is the moment? Force into distance is moment. I have already explained you previously. Moment is equal to force into distance. What is the distance between the free surface and force? Because of the center of pressure, force into distance is H star is equal to rho g into AH is for force. When you multiply with the moment of inertia, then that will become momentum. Moment is equal to force into H star is equal to rho g I naught. Please remember this when you take the moments about the free surface. When moments are taken about free surface, please remember this formula. There is one parallel axis theorem. What is it is called as? Parallel axis theorem. As per parallel axis theorem, I naught, that means moment of inertia about a particular axis is equal to moment of inertia about center of gravity plus area into height from that, distance from that surface or the point to the center of gravity square, h bar square, h bar square. This is a very important formula, parallel axis theorem. Why I am telling these things? Because in the examination like SSC, RRB or GATE, UPSC, you should understand the concept behind calculation of forces on different shapes kept on different geometries, kept in different orientations. One is horizontal orientation, second is vertical orientation, there can be an inclined orientation. We will be talking next now. Now, we can say by combining this formula, FH, what is the moment? You tell me. Moment is equal to force into distance. About which we are calculating the moment? We are calculating the moment to be calculated with respect to free surface. When you calculate moments with respect to free surface, force is F into H star, that is center of pressure. Pressure is acting on that particular center. Pressure is acting on here. This pressure force into H star is equal to moment about the free surface. Just I will draw another diagram to clear. Let us say this is the horizontal free surface. Please try to understand clearly. This is one vertical object kept. This is the center of pressure P. Pressure is acting at this center because pressure is varying with depth. And this is the distance H star from the center of pressure. Here the force is this way acting, and when the moment is taken with respect to this, what is happening? Movement is equal to force into h star. Distance is h star. That we say that rho g a into h. This h we are not knowing whether we should take h star or h naught or h bar. For that reason, what we have done, rho g we have kept it same, and we have told that we will take it as rho g I naught. I naught is the moment of inertia of this body, moment of area, we can call it as moment of inertia of this body with respect to free surface, moment of inertia, I naught. What is moment of inertia? A into h square, that is rho g into I naught. Rho g into I naught, what we have done, that is with respect to free surface. That is for what you call, for the whole body under pressure. Now, I will be taking only up to center of gravity. If I take, that is point G, which is at a height of h bar, which we know very easily from the geometry. Then with respect to h bar, the moment of inertia with respect to G is, that is moment of inertia of this body, and you have to add the area of this body multiplied by h bar square, so that we get it from with respect to free surface. Are you able to understand? With respect to center of gravity, I is equal to Ig, moment of inertia is equal to Ig. With respect to free surface, I is equal to I naught is equal to Ig plus A into h bar square. These two things please remember. About center of gravity, the moment of areas, that moment of inertia is standard. It will never vary, because center of gravity will never vary for a given surface, for a given geometry. For example, let us take a rectangular surface, and let us say this is like this, and this is the center of gravity G, and this is A, this is B, which implies, what is the Ig value? Ig is equal to about center of gravity. This is the center of gravity. Ig is equal to, for a rectangle, BD cube by 12. These standard values. You can see the derivations from the standard book, how it has come. Ig is equal to BD cube by 12 for a rectangle. B is the depth, A is the width, BD cube by 12. This can also be this here I will say this is B, breadth, width, this is B, and this is D, depth, breadth and depth, BD cube. And depth can also be, sometimes it can be H also, BH cube by 12, BD cube by 12. This is standard. That is with Ig is with respect to center of gravity. So area is equal to, let us write, area is equal to BD, height of CG from base is equal to D by 2. Now, this is about Ig. Now, can you find out I naught about base, so that you will understand how to calculate H is this what you call I naught for a different. As per parallel axis theorem, what is I naught? I naught is equal to Ig plus A H bar square. That is equal to, what is Ig? Ig is equal to BD cube by 12 plus A is BD into H bar is equal to height of CG. Height of CG, please try to understand, height of CG from the free surface, that is D by 2. D by 2 whole square. That is equal to BD cube by 12 plus BD cube by 4. That is equal to 12 BD cube plus 3 BD cube, that is equal to 4 BD cube by 12, that is equal to BD cube by 3. That means for a rectangular section, Ig about the center of gravity BD cube by 12, IO about base is equal to BD cube by 3. These values, why I am giving these values, so that you will understand the importance of these and you can easily apply for center of pressure, to get the center of pressure. Now, this is about the pressure on a vertical plane surface. For a different, I will give a homework. Here, let us talk about some homework. Homework is like this. You take the homework as find or collect values of area, moment of inertia about CG and about base for triangle, circle and a trapezoid. Triangle, circle and trapezoid. Now, let us move on to the pressure on inclined plane surface. Till now, we discussed about pressure on a horizontal plane, variation of pressure on a vertical plane surface. Now, pressure on an inclined plane surface. Now, inclined plane surface means how it will be? Inclined plane surface, this will be the fluid surface, free surface will be remaining the same, and the body will be like this. It's neither vertical nor horizontal, and it will make an angle theta with the surface. Then in this case, what will be the calculations? The calculations little bit differ. They include the angle theta, and when theta is equal to 0, the surface will be equal to horizontal plane surface. If theta is equal to 90 degrees, it represents the vertical plane surface. Now, let us write the corresponding equations, and in home you please try to resolve it. Why it has come so? Please try to understand. I will give the brief of it. Here, once we got the H naught, I naught is there. From I naught, we can find out H naught force, or we can find out. Now you see here we have from parallel axis theorem, I naught is equal to Ig plus A H bar square, F H star is equal to rho G into I naught. Rho G into I naught is nothing but, here let us continue, rho G into Ig plus A H bar square. Therefore, which implies H star is equal to what is the force? You please, from the definitions, you please try to understand what is the force. Force is nothing but Newton. What is Newton? Mass into distance by second square. Force is nothing but rho G by A H bar. This is the equation which you should remember. Sorry. This is not so. Force is equal to rho G AH bar. Then from this we will see that rho G into Ig plus AH bar square whole divided by rho G AH bar. Ultimately, we will get the result. We are interested in finding the center of pressure. Center of pressure is equal to rho G into Ig plus AH bar square divided by rho G into AH bar implies H star is equal to center of pressure height is equal to rho G will get cancelled. This will be Ig by AH bar plus H bar. This is the formula for center of pressure. We are interested in calculating the center of pressure. Center of pressure is equal to Ig by AH bar plus H bar. Now, in case of an inclined, this is for vertical plane surface. In case of an inclined plane, H star is equal to Ig, center of gravity, sin square theta by AH bar plus H bar. This is the formula for center of pressure for an inclined plane. Now, till now what we have done, let us see. We have found out the variation of pressure with respect to height as rho GH, normal stress, because we are now considering the fluid statics, hence there is no movement of the fluid, hence the tensile stresses are toe shear stresses are not taken into consideration, only normal stresses are taken. Please remember this point. And for a pressure on a horizontal plane, for this center of gravity, center of pressure is same. The height h is equal to rho g ah, pressure is force is equal to rho g ah, and for a pressure on a vertical plane, the center of pressure and center of gravity will be different, and using the parallel axis theorem IO is equal to Ig plus AH bar square, we concluded that center of pressure is equal to Ig by AH bar plus H bar. That is for a vertical plane surface. If the plane surface is inclined at an angle theta, then this comes as H star is equal to Ig sin square theta by AH bar plus H bar. Now, let us see. This is the final equation. Center of pressure is equal to Ig sin square theta divided by AH bar plus H bar. This is the final equation. As told already, if theta is equal to 0, that implies horizontal. That implies center of pressure is equal to 0 plus H bar, that is equal to H bar. Center of pressure is equal to height of the free surface from the center of gravity. Both are equal in case of horizontal surface. In case of a vertical surface, theta is equal to 90 degrees, implies vertical surface, vertical plane, that implies H star is equal to Ig sin square theta will be sin square 90 is equal to 1 Ig by AH bar plus H bar. For a horizontal surface, the center of pressure coincides with the center of pressure, the height of the center of pressure coincides with the height of the center of gravity. That is H star is equal to H bar. This is center of gravity height. Here center of pressure height. Whereas for a vertical it is H star, that is center of pressure height, is equal to Ig by AH bar plus H bar is for center of gravity plus H bar. For an inclined surface, this is center of pressure, this is center of gravity, and this is angle of inclination. Ig sin square theta by AH bar plus H bar. Now, pressure diagrams. For a horizontal plane surface, what will be the pressure diagram? The surface will be like this. What will be the pressure diagram? The pressure diagram will be, this is the horizontal surface. Isometric view I have given. Isometric view I have taken. Pressure diagram will be, for a horizontal surface, this will be, pressure will be like this, normal pressure. Then for a vertical plane surface, pressure diagram will be, what is the vertical plane surface equation? H star is equal to Ig by AH bar plus H bar. This is the equation for a vertical surface. Then pressure diagram will be, please see, pressure diagram will be, this is the vertical surface, pressure varies with depth, hence center of pressure also will be different for different combinations. Then the pressure diagram will be like this. The pressure diagram will be like this. This is for vertical surface. This is the vertical surface. For horizontal surface, it is like this, horizontal surface. For an inclined surface, what is the, for an inclined surface? Inclined surface, what is the equation? H star is equal to Ig sin square theta divided by AH bar plus H bar. This is for the inclined surface. Now, the diagram will be this is a free surface and the plane is like this, inclined at an angle theta, and this will be like this. This will be like this. I can say we can draw like this. And the pressure diagram will be like this for an inclined surface. Please remember this is the free surface. Don't get confused. This is the surface. On the surface, what will be the pressure at various levels. The last one is for inclined surface, second one is for vertical surface, the first one is for horizontal surface. This is horizontal. Now, in a question either in GATE or UPSC or SSC JE, if the question is given and graph is given like this, find out which is the horizontal surface or vertical surface or inclined surface, then you can find out from the diagram that this is inclined, vertical or horizontal. And another thing, for theta is equal to 0, it will be horizontal surface, horizontal plane surface, and for theta is equal to 90, vertical plane surface. For theta is not equal to 0 and not equal to 90, that will be an inclined surface. And the main formula is center of pressure H star is equal to Ig sin square theta by AH bar plus H bar, where H bar is the height of the free surface from the center of gravity of the plane, and center of gravity of the any plane is constant on the basis of the geometry. And for a rectangular plate, it is BD cube by 12, the moment of inertia, and with respect to center of gravity, and with respect to the base, it is BD cube by 3. And for a triangle, circle, and then trapezoidal, you please find homework. Already I have told you, add circle also. For circle, find moment of inertia. With respect to center of gravity and with respect to, we can say, bottom or top or bottom circumference, point or plane. Now, here H bar is equal to total pressure point. H star is equal to center of pressure. Please remember total pressure point position with respect to free surface, center of pressure position with respect to free surface. Please remember these two things. Don't get confused. Just for your final understanding, I will make like this. I will make a free water or fluid surface. I will take an inclined plane, because inclined plane means it's applicable for everything, and let us say it is center of gravity. This is the H bar, and let us say this is center of pressure, this is H star. H bar is total pressure point position from free surface, H bar. H star is equal to center of pressure position. This is center of pressure. This is center of gravity. This is total pressure point. This is center of pressure point. Now, we have understood and another is curved surface. There can be a curved surface also. There can be a curved surface like this. A surface can be curved. The surface of the plane can be curved. This is the free water surface, and if there is a curved surface like this, there will be center of pressure. There will be two components, horizontal and vertical, for the total pressure. For the total pressure, there will be horizontal component and vertical component, which implies the resultant total pressure is equal to square root of pH square plus, this is curved. It's not plane, curved. pH square plus PV square. PV is vertical, pH is horizontal. Resultant pressure is equal to pH square plus PV square. And angle of action of the resultant pressure is equal to, angle of action of resultant pressure is equal to, theta is equal to, direction of the resultant pressure is equal to tan inverse PV by pH. In competitive examinations, there can be a question on curved surface and resultant pressures, like they may give you theta and horizontal component and ask you to calculate the vertical component, or they may give the horizontal and vertical components and ask you to find out the direction, or they may give theta and horizontal component and ask you to find out the resultant. Once theta and horizontal component is given, you can find out the vertical component with the formula theta is equal to tan inverse PV by PH, or tan theta is equal to PV by PH. From this, you can find out the missing PV or PH, and we can put the values in this resultant square root of PH square plus PV square and find out the resultant force. The questions can be of different types. The questions on this fluid statics I will be covering in the next lecture, and very important and very interesting questions. I will not go into too much depth. I will be taking care of RRB JE, SSC JE, and in addition to GATE also. For UPSC, these foundations are required. Once you have the sufficient foundation, you can delve into typical difficult problems, and once I solve the problems in the next lecture, you will understand how the above science or the above lectures can be put into practice, and how different dams and gates are designed, and how in engineering and mechanical and civil engineering this fluid statics is useful. Best of luck to everybody, and it's Ramchandra again. I'll ask you to please view my videos, review my videos, and comment on them for further improvement. And this is what about fluid statics, which is a very important, little bit definitely a topic which requires your hard work and practice and do exercises, so that your concepts can be concretized, so that you can use them without any difficulty in the examination. These concepts are very important. Even in the soil mechanics, these are useful. Even in the designing of the dams, these concepts are useful. The pressure concepts, soil mechanics, and also in irrigation engineering also, these are important. Please try to understand these basics well, so that you can do better in the examinations. Best of luck to everybody. If you like my videos, kindly subscribe to my channel for getting the updated details of my videos. I will be on continuous basis for a longer period. I will be uploading the videos on civil engineering with different concepts, and in the first I have started with fluid mechanics. Once fluid mechanics is over, I will be switching over to the other topics. Best of luck to everybody. Thank you for listening to me.